Welcome back, everyone. We're diving deep into the world of Titan today. Saturn's largest moon, the one that's those crazy methane lakes and seas. We've got 3 new research articles that are shedding some light on, well, how Titan builds landscapes that look kind of like Earth.
Yeah, it really is a paradox when you think about it, huh? I mean, we see all these familiar features, dunes, plains, even stuff that resembles karst formations, but they're all carved from, well, organic compounds, not exactly the toughest stuff around.
No kidding. It's not like the hard rock we're used to seeing here. So how do these kind of flimsy materials hold up against erosion and create these lasting features? That's what gets me.
All right, so researchers at Stanford, they've discovered this super interesting process called sintering. Basically, Titan sand grains are kind of like baking themselves into rock.
Titan sand is baking itself. Okay, now you've got to explain that one. How does that even work?
Okay, picture this. You have a bunch of these tiny sand grains, right? And you heat them up a little bit. Eventually, they'll start to fuse together, become a solid piece. That's sintering in a nutshell. And on Titan, this whole process is driven by internal heat and pressure from all the stuff piled on top. It basically makes those organic materials tougher, more resistant to erosion.
It's like the sand is going through its own little forging process down there.
Yeah.
That's pretty wild. But how does this explain the different landscapes we see across Titan? I mean, we've got dunes, plains.
Well, that's where the wind comes in. Near the equator, the winds are really strong, so there's not as much time for the sintering to happen. How you get those giant dune fields. They're made of fine sand that gets blown around really easily.
Got it. So the wind is preventing the sand from baking together too much, right? What about those smoother plains we see?
Exactly. Those are at the mid-latitudes where the winds aren't as strong, so the grains have more time to sinter and fuse together. They get larger and coarser, and in some cases, they can even, bind together completely, become solid bedrock, basically. That's how you get those wide-open plains.
So it's kind of like a gradient, right? Strong winds, fine sand, dunes, weaker winds, bigger grains, plains. Makes sense. Now, what about those labyrinth terrains? Those are near the poles, right? They look so bizarre.
Yeah. Scientists think those are kind of like karst landscapes that we see on Earth. Those landscapes where acidic rain dissolves rock, creates caves and sinkholes. On Titan, it's likely a similar process, but it's methane rain dissolving organic sandstone, which is more common in the polar regions.
So we've got wind, rain, and some underground baking. Titan's got it all. What about the seas, though? Could there actually be waves on a moon with seas made of liquid methane?
Well, some researchers at MIT, they decided to tackle that question. Trying to spot waves directly is tough. Titan's pretty far away, and there's that hazy atmosphere. So they took a different approach. They looked at the shapes of Titan's shorelines.
Shoreline sleuthing. I like it. But how can the shape of a shoreline tell you if there are waves or not?
They modeled 3 different erosion scenarios, right? One with no coastal erosion at all, one with wave-driven erosion, taking into account what's called fetch, the distance wind can travel over, a body of water, and then one with just uniform erosion, maybe from the sea, slowly dissolving the shoreline. Each one creates a different shoreline shape.
So like a fingerprint, the shape of the shoreline tells you what's causing the erosion.
Exactly. And when they compared these shapes to the actual shorelines of 4 of Titan's biggest seas, the results pointed pretty strongly towards wave-driven erosion.
Waves on Titan. I gotta admit, I didn't see that one coming. Okay, we've got wind-blown dunes, rain-carved labyrinths, and now waves crashing on the shores. Titan is shaping up to be a pretty dynamic place. But what about those magic islands we keep hearing about?
Yeah.
The ones that pop up and then vanish in Titan's lakes? Are those formed by all these forces too?
That's where things get even more interesting. To understand that, we gotta dig into what happens to those simple organic molecules that rain down on Titan's surface. Researchers at the University of Texas, San Antonio, they've found some pretty cool clues.
All right, so we've got organic rain. But what happens when it hits those methane lakes? Does it just, disappear?
Here's the thing. Most of those simple organics, the nitriles and hydrocarbons, they actually land as solids. They don't just dissolve into the liquid.
Wait, so you're saying there are chunks of solid organics just floating around in those lakes? Could those be the magic islands we've been wondering about?
It's definitely possible, but there's a catch. Most ice is denser than the liquid in those lakes, so it should sink. So how do these solids stay afloat long enough to create these temporary islands? That's what the researchers had to figure out.
Okay, now I'm really intrigued. How do they stay afloat? What's the secret?
They figured out 2 things are key: porosity and contact angles.
Porosity, like the holes in a sponge, right? And contact angles, that's how a liquid spreads on a surface. But how do those things explain floating islands?
Think of it this way. If you have an ice particle with enough pores, it can trap air. That makes it less dense and helps it float, like a little organic life raft.
Clever. So what about contact angles? Where do those fit in?
Well, the angle at which a liquid meets a solid surface, it determines how much they interact. If the contact angle is high, the liquid has trouble spreading out, and that can create a buoyancy effect, helps things stay afloat.
Okay, so are we talking sponges or contact angles here? Which one is the more likely reason for those magic islands?
Their calculations point to porosity being the more likely culprit. They found that for most organic ice to float, it needs to have a porosity, like similar to, terrestrial snow, lots of air pockets.
Giant snowflakes of organic compounds drifting on those methane lakes. Now that's a picture. But wouldn't they, eventually melt or dissolve? These magic islands aren't permanent, are they?
Right, and that's where particle size becomes important. The researchers found that, small particles like those you'd find in snowfall or sand, they would sink pretty quickly. The liquid methane would seep into the pores and make them heavier.
So we're talking big chunks of ice then, like mega snowflakes.
Exactly. They think the magic islands are probably these large, porous, organic ice particles, maybe, several millimeters across or even bigger. They can float for a while, but eventually they become waterlogged and sink.
So imagine these huge porous chunks of organic ice just drifting around on those alien lakes. Sometimes they clump together, create these bright spots on radar, and then poof, they're gone, like a cosmic magic trick.
It is, and it really shows just how dynamic Titan's landscape really is. I mean, we've got winds shaping dunes, rain carving those labyrinth terrains, waves hitting the coastlines, and now maybe these giant floating icebergs of organic compounds just adding to the show.
Titan just keeps getting more and more fascinating. This has been an awesome deep dive so far, but I'm ready for more. What other insights did these research articles have for us?
Welcome back to our deep dive into Titan. When we left off, we were talking about those magic islands maybe being these huge chunks of organic ice floating around.
It's crazy to think something like that could be happening out there.
Yeah.
You said this research is groundbreaking, but how so? What makes it so important in the grand scheme of things?
Well, it's not just about figuring out this one mystery, It's about the bigger picture. The fact that even though Titan's made of such different stuff than Earth, the same forces are at work, shaping the landscape in surprisingly similar ways.
So even though Titan's this alien world with methane lakes and organic rain, it's still following, like a playbook we recognize.
Exactly. It's like nature is playing the same tune, just with different instruments. We see erosion, deposition, wind-driven processes, stuff we see here on Earth, but with a Titan twist.
Okay, I'm starting to get why scientists are so obsessed with this moon. It really is like this giant natural laboratory where we can study these processes, familiar but still alien. What about life, though? Could anything actually live in that environment?
The million-dollar question, right? It's definitely generating a lot of excitement and debate. Life on Titan would be, different from what we know, but the organic molecules, the liquid hydrocarbons, that dynamic climate system, they all point to a world that could be habitable.
I'm trying to imagine life in a methane world.
Yeah.
What would it even need to survive? What are we even looking for?
Well, on Earth, life needs liquid water, a source of energy, and the right chemical building blocks, right? Liquid water might be scarce on Titan's surface, but there's evidence there could be a subsurface ocean. And energy, Titan's got plenty of that. Sunlight, internal heat.
Okay, energy, maybe water deep down. What about those chemical building blocks? Are those similar to what we see on Earth?
No, that's where it gets really interesting. Titan's atmosphere and surface are full of organic molecules. Hydrocarbons, nitriles, even these more complex compounds called tholins, they form when sunlight hits Titan's atmosphere.
Tholins. Sounds like something out of a sci-fi movie. What are those exactly?
They're these complex, reddish-brown organic molecules. Scientists think they could be precursors to the building blocks of life, imagine them as the raw ingredients in nature's prebiotic soup, just waiting for the right conditions to spark something extraordinary.
Wow, so we have a potential energy source, maybe liquid water, and a whole mix of organic molecules. Sounds like Titan's checking a lot of the boxes for habitability, at least from our Earth-centric perspective.
It really is. That's why a lot of people think Titan's one of the most promising places in our solar system to look for life beyond Earth.
This is mind-blowing. But if life does exist on Titan, what would it even look like? Could we even recognize it as life?
Now that's a question that's got scientists really thinking. Some picture life forms living in those hydrocarbon lakes and seas, maybe using methane like we use water. Others imagine life in that possible subsurface ocean where things might be more like Earth's deep oceans.
Trying to picture a methane-based life form is really pushing my imagination. But you're right, the possibilities are pretty much endless.
Exactly. We could find creatures that breathe hydrogen, not oxygen, or organisms that use acetylene for energy. It really makes you rethink what life could be.
So we've got wind, rain, waves, maybe even ice volcanoes, and the possibility of life as we don't know it. It's amazing to think that just a few decades ago, we knew so little about this place. It was just a hazy orange dot.
Yeah, it shows the power of exploration. The more we learn about Titan, the more we realize how much more there is to learn. Speaking of exploration, I can't wait to see what the Dragonfly mission finds when it gets to Titan in 2034.
Dragonfly. That mission is going to be epic. A drone flying around Titan. It's like something straight out of science fiction. Can you remind everyone what Dragonfly will be doing over there?
Of course! Dragonfly is going to be our eyes and ears on Titan, exploring all sorts of environments, those dune fields, impact craters, maybe even those methane lakes. It's got instruments to analyze the surface, look for signs of life, study the weather and climate.
Wow, so it's not just about snapping cool pics. This is serious stuff.
Oh, absolutely. Dragonfly could completely change our understanding of this moon, give us an up-close look at the landscape, the atmosphere, maybe even some clues about the potential for life.
Okay, I'm adding watch Dragonfly land on Titan to my bucket list. But before we get too far ahead of ourselves, there's one more mystery we need to unravel. What about those organic deposits? What do they tell us about Titan, and why should we even care?
This is where we circle back to Earth. Turns out, studying how those organic compounds settle out of Titan's lakes might help us solve a mystery much closer to home, in the Dead Sea.
Hold on. The Dead Sea? That's super salty lake here. What's that got to do with a moon full of methane?
It might seem strange, but it all comes down to deposition. You see, the Dead Sea is known for its crazy high salt content, leads to those cool salt formations along the shores.
Yeah, I've seen pictures. They look otherworldly. I still don't see the connection to Titan, though.
Well, Titan doesn't have salt, at least not the kind we know, but those organic compounds that rain down, they can precipitate out of those methane lakes, build up over time, just like salt does in the Dead Sea.
So instead of salt crystals, we could have these deposits of solid organics along Titan's shores. That's wild. But how does this help us understand the Dead Sea?
It's all about these evaporate environments. Titan's methane lakes and the Dead Sea, they're both places where liquids evaporate, leaving behind solids. By studying how those organics settle on Titan, we can learn about the things that affect evaporation and deposition in general.
So using Titan as this giant lab to help us understand stuff happening here on Earth, that's pretty clever.
It is, and it proves a really important point. Scientific knowledge is all connected. Sometimes, the most unexpected links can lead to the most amazing insights. By studying the alien, we learn more about ourselves.
Well said. I'm starting to appreciate how complex, how interconnected this all is. But before we move on, anything else about those organic deposits? Could they tell us anything about the possibility of life on Titan?
That's a great question, and scientists are working on it. These deposits could hold evidence of past life or even the ingredients for life to start in the future.
Wow, a time capsule of Titan's history. Maybe even a glimpse into its future. Incredible.
It really is. And it reminds us that we've only just started to understand what Titan has to teach us. With missions like Dragonfly coming up, the next few decades will be an exciting time for anyone interested in this moon.
Absolutely. But before we get ahead of ourselves and start planning trips to Titan, there's one more fascinating thing about this moon we need to explore. Turns out, understanding Titan's landscapes might actually help us solve a mystery right here on Earth. Ready to dig in? All right, you've got me hooked. What mystery on Earth could be connected to Titan's landscapes?
You know those organic deposits we've been talking about? Well, there's a pretty cool link between those and sinkholes, especially in karst areas.
Wait, sinkholes like the ones that just open up and swallow cars and houses? What do those have to do with Titan?
It might seem like a stretch, but the processes underneath are actually pretty similar. Remember how those organic compounds rain down on Titan and build up in the lakes? A similar thing can happen in those karst regions on Earth, just with different stuff.
Okay, I get that karst landscapes are formed by acidic rain dissolving rock, making caves and those underground channels. But where do the deposits fit in?
Well, over time, those underground channels can get clogged up. Sediment, debris, you name it, it creates like a plug.
And then when it rains more and the water table rises, The pressure builds up under that plug.
Exactly. And boom, the ground gives way. You get a sinkhole. Now here's where Titan comes in. By studying how those organic deposits form on Titan and how they could clog up those channels, we can learn about what might cause sinkholes here.
So it's like we're comparing notes between two completely different worlds. But there's that common thread, the way liquids move and deposit stuff.
Exactly. It's a great example of how studying planetary processes on other worlds can help us understand, maybe even prevent, geological hazards here on Earth.
That's amazing. I never would have thought Titan could teach us about something like sinkholes. It really shows how connected everything is.
It does. And it reminds us there's still so much we don't know, even about our own planet. Looking out to other worlds gives us a fresh perspective, even on things we think we understand.
This whole deep dive has been full of surprises. Sintering, waves on a methane sea, those magic islands, maybe even life, a connection to the Dead Sea, and now sinkholes. What a ride.
It's amazing what we've learned from just these 3 research articles, and it's just a tiny peek into all the knowledge that's out there.
Makes you wonder, what other secrets is Titan hiding? Can't wait to see what missions like Dragonfly uncover.
I know, right? It's such an exciting time for planetary science. Who knows what's waiting to be discovered out there?
Well, that's a wrap for our deep dive into Titan's dynamic landscape. Hope you all enjoyed the journey as much as we did.
It's been awesome exploring these findings with you.
And as always, keep looking up, keep asking questions, and never stop exploring the universe.